Piecewise functions are functions where the domain is broken up into intervals and the value of the function is defined differently on each interval. So a general piecewise function looks like this. You usually see the brackets, and then you have the values or the definition of the function, let's say, defined for each interval. So it'll look like this. It's quadratic between 0 and 1. And it equals x between 1 and, whoops, 2. And it equals a constant at the interval 2 till 3. So the way I set this up in space is it's a function. It is piecewise cut into however many intervals. In this case is 3. So then I would show that the function is defined like this. This is the quadratic. This is the x, and it equals 1, constant. On the graph, it looks like this. Now you're including 0 because it's less than or equal to 0. So, and it's going to be the square of the input. So it's going to look sort of like a parabola. Let's make that look like a parabola. And it has the open, it's a closed to an open interval. This means that it includes the point. This means it does not. Between 1 and 2, it just equals x. So this is going to get filled in for that. And then up there, it's going to be a circle. Then it equals 1 constant on that interval. So that is a general piecewise function. Sometimes you'll see it abbreviated piecewise. Next, I have 3 examples of types of piecewise functions. There's a step function, a floor function, and a ceiling function. And I'll show you what they look like now. So everything is going to stay pretty much the same for a step function. However, the values or the way the function is defined on each interval, they're all constants. So it looks like steps. Doesn't really look like a staircase, but it will look like steps. Sometimes there is something called a staircase function that ends up looking like a staircase. We'll see those next. But a step function would be defined, let's say, something like this. On the first interval, let's say it equals 3. On the second interval, let's say it equals, wait, we don't want it to look like steps. So we'll say it equals a 1, and then it equals a 2. On the graph, then you're going to have, whoops, something like this. Step function. Now we'll move on to a floor function and a ceiling function. I just signed them very generically. But the symbology, well, I'll show you what that looks like next. So now we are on to floor and ceiling functions. A floor function, what it does is it takes the input, takes the x value, and it rounds down to the next integer. You could also think of it as just cutting off the decimal places of the number. So the symbology looks like this. You notice we got rid of the brackets and all that. All we have now is that, and that shows it. Basically, it looks like an absolute, but it has these little a little floor installed at the bottom. That's how you know it's a floor function. And what that looks like, now you have to be careful with the open and closed intervals for a floor function, because you're always going down, you're going to see them arranged this way. For a ceiling function, you'll see them this way, and I'll show you. So here's the floor function. Now, if the input is anything between 0 and 1, but not including 1, it equals 0. Again, we're rounding down to the next integer. Integers, remember, it's this symbol, it's that double Z kind of looking thing. So then any x values between 1 and 2, not including 2, and so forth. So now you actually see what looks like steps. And sometimes this is called a staircase function, because that's what it looks like. Now we'll go back to a ceiling function. Oh. Okay, now the ceiling function, same idea, except the symbology is just reversed. It's the x with the ceiling on top of it. Now, this is the one where you got to remember to sort of flip the open and closed notation. So anything between 0 and 1 for a ceiling function, now we're rounding up. So between 0 and 1, we are now rounding up. That's what it looks like. Piecewise functions.